Before starting of it, I would like to ask, who is using Terraform here? Okay, it's good. So I'm Yuliia Barabash, I'm cloud engineer, and I use AWS, Python, and Terraform on a daily basis. And today, honestly, I would like to share about my pain of using Terraform. Because if you build everyday Terraform components, Terraform infrastructure, sometimes it can be very annoying. And that's why I want to talk about how SDK can solve our problems. So let's start just with recap, what is Terraform? Basically, Terraform is a framework what we use to declare our infrastructure. It means we don't need any more click ops. Somebody is just going, nice dude, who is we can think about him as Terraform, and do this job instead of us. And we just in Terraform files, today we'll learn how to do in Python, how to do this in Python, declare what resources what we have. And if we think about Terraform, we also can think about him like this. He just on daily basis click different buttons and AWS and just fix our infrastructure and thinks everything is fine. Great. Just small recap what main components Terraform has. So Terraform has providers. It's usually APIs that Terraform is used to communicate with external APIs. So basically it's GCP, Azure, Git, AWS. Other important factors, it has resources. Resources basically represent different units in AWS, for example, S3 bucket, Lambda, who is using cloud function in GCP. Azure, I don't know, unfortunately. But for this, we define resource blocks. I will have also example of small resource block. Other one is variables. Variables is also very important because with variables, we can define setup for different infrastructure, for example, for in, dev, and prod. And for example, we don't want to have some EC2 instances deployed to the int. We want to have different type of instances to save our costs. In via variables, we can define it. Outputs is very nice. It's what we check what was deployed to AWS. For example, we know that in AWS, some resources names, for example, Lambda's IDs, REN is only, we only know after creation. And usually in outputs, we can check what was created and also have some custom variables in the output. And the final TF state is basically where we keep our state. So Terraform knows what was created, what was deployed, and what we need to destroy. So basically, he keeps track of it. And let's talk about Terraform. So basically, here is a simple example. I just want to recap it. What is the Terraform is used resource block to create resources. It means if you want to create, for example, Lambda, you need to define Lambda, layers, roles, attachment, triggers, and it's a lot of things to define. Here we have example where it defines the type of resource, name of the resource that it's, and some properties. And as I mentioned, Terraform is very easy to use, but it comes with a price. And a price is that it has own limits. For example, it doesn't have good loops, functions, or conditions. For example, if you want to loop over some, it's there's for each for resources you can use, but sometimes it's very painful to have very complex loops. And for example, for me, it was very hard to filter out, for example, some files, and usually it was very painful. Another one, poor code reuse and abstraction. So usually it's copy-paste driven development. You just copy, change something, and you have a lot of repetition. Another one is it's hard to write tests. For example, in Terraform, there's Terra test. It's usually what is used by, it was implemented in Go, and you can just test real implementation, real deployment. You cannot just what you write. And also we support with some with Python hints, auto-completion. It's very hard also if you have a big project, it's very hard to orient of this. That's why they decided to create Terraform together with Python. It means that it's possible to, it means that right now it's possible to use Python, Java, TypeScript, or other programming languages. No, Java, TypeScript, C# for creation of the Terraform. It's very important because we can use similar syntaxes for us in Python to create AWS resources or in other infrastructure. And it gives us a lot of capabilities. For example, it gives capabilities to use Python ifs, for loops, class, functions. It can be more flexible and easy to understand. Other is give also powers and inheritance. For example, we can inherit something for object. We can add additional properties, and we can use it. Later, I will show you how to do this. And another one, we can test our infrastructure as well. For example, it's possible to test Terraform CDK by defining some properties. It's possible to use PyTest for our Terraform CDK as well. And also simplify managing of multi-environments. Because here you can use complex setup, you can use complex variables. It's way easier to manage your infrastructure. So let's talk about Terraform CDK. So right now, Terraform supports a lot of different resources, how we can manage, how we can declare our resources. TypeScript, Python, one of them, but also it comes with this price. We can see we still use our Terraform under the hood. It means it's the same that we use for HashiCorp declarative language and the same that can be used by Python. But how usually it works? The idea of this is that it has also new components. It has also a component of the construct. It's basically the smallest business units that you can represent your object. For example, you have, as I mentioned, let's suppose we have event-driven architecture. In the event-driven architecture, you have a lot of different lambdas. And lambdas can be triggered by different stuff. For example, it can be triggered by SQS, DynamoDB, CloudWatch, API Gateway. And usually, construct represents the smallest business unit. In our case, it will be simple lambda. It means with this construct, we can define our lambda, we can define our lambda layers, we can define how we compile code for our lambda, how it build it, and can be reused across your project. You don't need to copy paste. It's like custom modules, what is possible with community, but you can define construct. It basically will be a class. It will be example a bit later. Also stack. Stack is also part of your infrastructure. So at the end, you have big infrastructure, but your infrastructure can be split in business units. For example, we have for metrics, we have for data collection, we have data processing, and some data loader. And here stack is basically can be for metrics. So there's a lot of lambdas that connected to the business topic, business area of metrics. At the end, we have app. So it's representation of your whole application. And usually at the end, it will be like a tree. So up, it will be upper level, it will be root, but on the second level, it will be a lot of different stacks that will represent each business unit. Inside will be, for example, smaller business units, like example, lambdas, S3 interconnected, that will be just dedicated to this stack. It's way more organized than what we have right now with Terraform. And providers, what I like, we still can use native providers as Terraform because we still use our Terraform. And as I mentioned, everything comes with its price. Even we have Python right now for managing resources for Terraform. We still use Terraform agent for compiling our infrastructure. What does it mean? That we define our Terraform in the Python. But later, we need to execute SDK things. What does it mean? It takes our Python files and compile in and store it, synthesize usually, in the JSON. It means JSON will be a representation of all resources that will be created. And after it, we will have our JSON. And basically JSON, what Terraform will be used to deploy to infrastructure. Why it's important? It's important because when you write your Python code, you won't most probably use some external libraries. For example, you want, okay, I want to do API calls to fetch some data. But in this case, if you want to use with Terraform, you need to understand what happens exactly when. For example, for SDK TF, since at that moment we parse everything that has to be deployed to the AWS. And at that point, we also parse our Python code. It gets executed. For example, if you want to do some request, at that point, that request will be executed, not the point when it will be delivered to the AWS. That's why it's important to understand. If you want to use custom resources, please still use null resource to do custom logic and execute Python scripts. It's not possible with SDK TF to execute just call method. And after deployment, we can end up is 100 EC2 instances in AWS account, because we have right now loops. So let's go over our construct. Construct is the smallest business unit and CDK, Terraform CDK. What does it mean? As I mentioned, it can be a representation of your, for example, the smallest business units that you want to run. And usually it can be defined as here, that we can just define class, base lambda function, construct. We inherit this from the construct. It's also upper level class. Usually it has some definitions. For example, it has some methods that will be called internally for parsing your lambda. For example, how it should be deployed, parsing some metadata, and then will be stored in JSON. After that, we just call init. Inside we pass scope, ID, and, for example, bucket name. What we have to pass is a scope. Scope is important because basically we pass the parent. And we pass this parent to define this tree to connect between the cell, connect like construct to the stack and stack to the app. And after that, all these business units know how to connect to each other. And it's example of creation of lambda function. So to define just lambda function, we need to call lambda function call, specify name, handler, Python venture, also a file name, and role that we want to execute. But as I mentioned, it's possible to use inheritance. And what advantages of inheritance here? As everything will be defined in classes, it means that we also can inherit from our classes and add some business logic. For example, here we can define SKS trigger. As I mentioned, Lambda can be triggered a lot of different ways. It can be defined by SKS trigger, CloudWatch, DynamoDB, and also have different properties. Some Lambdas run inside VPC, some doesn't run around VPC. And you can have some predefined conditions for your base Lambda, and after that, you inherit from these properties to other Lambdas and add additional capabilities. And it's very useful because usually in Terraform, when I need to do this stuff, it's quite painful. Because who knows Terraform, you know that if you want to do something, create conditionally, you need to use counter. And basically in counter, you specify, okay, I want to enable SQL trigger, or I don't want to enable. And depends of what I want to trigger, you need to define. And also, my personal pain is also using dynamic blocks inside resources just to define optionally, I want to apply this, I don't want to apply this. So I think with SDK, it's much more powerful and much more flexible. Variables is my favorite part. Why is my favorite part? Because with variables, we can use identical objects. And it's cool because we can define our constants, we can define our validations, we can define proper types, we can define the smallest value, the biggest value, what kind of value we can accept, and also validation for some of the properties. And basically use across your project. With Terraform, we know it's also the biggest challenge in Terraform is variables, because in Terraforms you have just predefined set of variables that you can use. You can use string, in, boolean, set, list, and for example, for a lot of community modules, there's possible to define Terraform variables. They define, when they have complex Terraform variables to accept, they just define type any, and then you don't know what you can pass inside that any variables with the type any. So you spend just hours going through documentation and understand what you need to pass. Also, it's very hard to define optional values. For example, here you can see there's duplicates. Why we have duplicates? Because some of the values I want to have default values. For some of them, I don't want to have default values. And usually, it's what I don't like in Terraform, and usually I end up at the end of the day like this, because I spend a lot of timing just fix Terraform variables and make it work, but yeah. Another one that I like, it's stack. Stack, as I mentioned, is basically a representation of your smallest business units that you're going to execute. Not the smallest, it's just part, like a container that you can have inside, your Terraform. So basically, in that container, you can have a lot of smallest business units. In our case, we want to create just a bunch of CloudWatch lambdas. It means, like right now, we also inherit something from Terraform stack. It has also parent class that define behavior, how we're going to parse it to JSON. And after that, we define that we want to create CloudWatch lambdas, and it will be executed inside stack. Will be stored with this. Why I also like this? Because in our case, we have very big infrastructure, and one of the pains also that we have circle dependencies. In this way, we have a lot of deployments, so we need to separate our deployments, so we somehow can switch this logic. In our case, it's very easy because these stacks are independent, so business units that defines with these business units, they will not overlap, but you can still at the same time deploy the whole application, and you don't just need to do not run one after another one because you're afraid that something will overlaps. And here, basically, we just loop over all configurations that we pass, and it will create a CloudWatch lambdas for us. And app is the final part of us, because app is basically context where we define our infrastructure. And for this, you just create instance of the app. Inside of it, you call lambda collection. It means that it's the stack that we created. And after that, you specify the ID, configuration. Also, you pass the app. It's like parent of your root. So we can still define this tree. And things will be parse everything to the JSON. And that JSON will be picked up. My conclusions. It's very nice to... it lets you write infrastructure using real code, Python, Java, TypeScript. Also, it's gained a lot of reusability validation. And also, it's possible to define tests. Also, under the hood, it still uses Terraform. It's a lot more flexible, and it's a lot more useful. But if you ask me, Yuliia, if you're using this in production, unfortunately, we're not using this in production. What of the main reasons? I'm still trying to do this for pet project. But why of the main reasons we are not using this? Because right now, it's still under version 1, but it's not that popular. So it has a lot of capabilities, a lot of things, but for example, it missing documentation. For me, it was the hardest to understand the documentation because, for example, I need to understand how these all resources I can define. There's no good documentation in the internet, but when you started to use, when you're going to these classes inside your library that it's going to install, there's good definition of all the classes. Also, what else? This is they developing it, but unfortunately, there's no so much people is using. That's why it's very hard to find information, but it has a lot of benefits over the simple Terraform. And that's all, and thank you for your attention.
Thank you, Yuliia. So if there are any questions, please line up at the microphone.
Hello. Thanks for the talk. Do you know if the Terraform CDK is compatible with TerraGrunt, like the orchestrator for Terraform?
This, unfortunately, I don't know, but Terraform CDK is compatible with Terraform. So all modules that you run in the Terraform CDK, at the end you compile, you publish somewhere, and you can use as sub-modules. So Terraform CDK is compatible with Terraform, and Terraform is compatible with CDK. So I think it should be also compatible with your tool for orchestration.
Okay, so you can have a CDK module and then publish it as a Terraform module, and then it's used by something else. Okay.
Yes.
Great, thanks.
Yeah.
Hi, thanks for the talk. We have some sort of issues sometimes where we want to rename resources, and Terraform tends to delete the resources and create them again. And I was wondering, is there maybe a way to build sort of migrations with Terraform, or is it maybe possible to use this for creating those linear migrations?
Unfortunately, no, because as I mentioned at the beginning, Python code will be compiled and parsed in the JSON. So, and Terraform just pick up JSON and will destroy or create resources that define in JSON. It's also what upset me as well, because in our case, we also, I thought it also will be a way from good help for us, because we also run a lot of Python code. Sometimes we run Python code from our Terraform because we have import of data or we need to retrieve some information for our infrastructure. But I think it will not possible because it doesn't have like post creation or post destroyed after your resources. Okay. So no.
Okay, yeah. Thanks.
Thanks for your talk. I'm wondering if it's possible to migrate somehow existing Terraform to this, or maybe mix together?
It's possible to migrate. So there's like, right now I cannot tell you the name of the command, but is it possible to migrate? There's commands that will parse your Terraform and will, I don't know what will be quality of it, of course. But I think it's possible, and also as I mentioned that it can be mixed. For example, modules that was published but created in Terraform or Terraform CDK can be imported to another Terraform. So if you publish in Terraform CDK, you can import to your Terraform and use it. But the problem is you cannot specify as a source. So if you have, because with module you can specify S3 bucket, you have GitHub, and also you can specify the source where it's located. But source under like subdirectories you cannot use. But if it's published, you can import it and use it. So they also like interconnect. You can use them together. But it depends if it's a good strategy to use them together. So, yeah.
Thanks.
Yeah, thanks again for your talk. It was really interesting. I just wondered, you say you're not using it in production yet. I've been keeping an eye on the Terraform CDK as well, and I just wondered, like, based on using it, what's your rough feel for how long it might take to be sort of production ready from HashiCorp, do you reckon?
It depends. It depends what kind of. Can you repeat one more time?
How long do you think it will take to be production ready to use the Terraform CDK?
Honestly, I thought about this. It's a very good question, and I think it depends on how much community invests in this. That's why I decided to mention about this CDK, because it's nice, but I think it's not well promoted, because on the forums I just found a few articles. Documentation is very hard to also to understand, and not a lot of people contribute. That's why I decided to talk about this, also to promote, because it can solve some challenges. I think it's quite product. It's hard to say how it's like ready to use. It more depends on the community, because community helps to, for example, if there's new updates in AWS, usually it's community who brings the latest changes, and it's this quite important factor. Yeah.
Cool. Thank you very much.
I think we'll make this the last question because we're just starting to run out of time.
Hello, thanks for the talk. I have quite a basic question. So I'm quite new to DevOps, so I don't know if it's going to make sense. But what is the difference between your presented solution and the way of managing infrastructure in an SDK provided by AWS like Boto3?
This one from AWS I didn't try, but I think it's more like you have possibility to be multi-cloud. So, for example, with AWS, you have only connection with AWS. But in case you want to be multi-cloud, it's way more, or cloud agnostic. I think it's better to use Terraform. So it's very hard what's the difference. They even was inspired by AWS CDK, but for me it's very hard to tell what's the difference, because I need to try AWS CDK.
Okay,
Yeah.
Thank you.
Okay, thank you very much. Can we have a big round of applause for Yuliia, please?